Hi students. Okay, so the problems that are left to discuss is number 20 and 26 on chapter 7 in our 5 Steps for 5 AP Calculus AB book. So number 20, it says, this one right here, it says write an equation of the normal line to the curve x times cosine y equal to 1 at 2, pi over 3. So let me write that equation down. X cosine y equal to 1 at 2, pi over 3. And we want to find the normal line. So what is a normal line? Normal line is a line that is perpendicular to the tangent line at the point of tangency. So if I just draw a curve like so, and here is my a comma f of a, and I have a tangent line right here, then the normal line is this one right here. That would be my normal line. And so all you really need is a point and a slope. So we'll have this point, which is given to us, and the slope. And how we determine the slope, it is the opposite sign reciprocal of the tangent line. So what we need to do first is we need to take the derivative of this and find the slope at this point. So we're going to use the product rule. So 1 derivative x is 1 times cosine y plus then x times the derivative of cosine y is going to be negative sine y, and then dy dx for implicit differentiation is equal to, and derivative of 1 is 0. And so then we're going to need to solve for dy dx. You don't have to solve for dy dx here. You can just start substituting in the values. And that's a good strategy to do on your AP test. Don't spend time getting the expression dy dx is equal to. Just start substituting values if you have them already. So 1 times cosine, your y is pi over 3, plus your x is 2, and you're going to have negative sine of pi over 3 times dy dx. And that's equal to 0. And cosine of pi over 3 is 1/2. And sine of pi over 3 square root of 3 over 2. So this is plus 2 times the square root of 3 over 2, but our sign was negative. And then dy dx is equal to 0. So that's what I get after substituting in. And so now I have 1/2 minus square root of 3 dy dx is equal to 0. And so subtract 1/2 and divide by negative square root of 3. You have dy dx is equal to positive, I better subtract, negative 1/2. And then, so dy dx is equal to, I'm trying to remember, divide 1/3 square root of 3 multiply by the reciprocal. So that means that this is going to be 1/2 square roots of 3. Sorry, that was a challenge. Okay, and so that is what your dy dx is equal to. And so this is the slope of the tangent line, but it's not the slope of the normal line. So the slope of the normal line is negative, opposite sign, and then reciprocal, 2 square root of 3 over 1, like so. That's the slope of your normal line. And so then, now you want to find the equation. And so y minus your y value, which is pi over 3, is equal to, now your slope, it's not going to be f prime because it's not the derivative of the tangent, but it's the slope of the normal line. So it's going to be negative 2 square roots of 3 and then x minus 2. And then you can simplify this if you want. If you want to distribute this in and move this over to get it in slope-intercept form, that's really up to you. And if it was multiple choice, then you want to look for the appropriate form that it's going to be given in. Okay? And so now, number 26. Number 26 is... this problem right here, limit as h goes to 0 of sine pi over 2 plus h minus sine of pi over 2 all over aj. H goes to 0 of sine of pi over 2 plus h minus sine of pi over 2 all over aj. Now, hopefully, you remembered that this looks like the form of the definition of the derivative. And so, this is not an x, this is a value. So, you should match it up to this. F of a plus h minus f of a all over aj, which is equal to f prime of a. And so you're trying to find out what this expression is equal to. And so that means that you need to find out what your function is and what your a is. And your a is easy to determine because it's what you're adding to your, h. I did not copy it down properly. That would make a difference. Okay. And so it's what's adding to your h. So it is pi over 2 plus h. So now, a is equal to pi over 2. And so you now know what your a is. Now what is your function? So f of x is equal to sine x. The f, both of these are s. What is the function that is acting on this expression? And what is the function that is acting on my pi over 2? And for both parts of the numerator, it's sine. So it must be sine x. So then that means that this part right here is actually equal to f prime of pi over 2. And so now let's go find f prime of x. So f prime of x is equal to cosine x. And so then f prime of pi over 2 is equal to cosine of pi over 2. And cosine of pi over 2 is 0. So therefore, this limit is equal to 0. And that would be your answer.